Hello everyone and welcome to another episode of Solving Advent of Code in Rust and Trying to Learn Rust. I'm Roberto. Then there is somebody.
Eugene?
Yeah, thank
Luciano.
you.
Oh, my microphone didn't work.
Now it's working.
Now it's working.
Yeah, thank you everybody for following along. If you never did Advent of Code is a code challenge that is published every year in the Christmas period. We are working on the last year one because this year is not here yet. There are 24 challenges, and you can find them on adventofcode.com. We are publishing all our code in a GitHub repository.
This is Advent of Code, and this is the repository.
Perfect. And also we have a YouTube channel where you can find the recording of this, and the links are in the Twitch channel if you are watching on YouTube, to the vice versa process. Last time we were doing exercise 18, we finished it, so now we are moving today to exercise 19, part 1. Okay, yeah, who is going to read the README and explain the explanation?
Cool, so I'm going to try to do that, but feel free to interrupt me if it's not clear. So I'm going to leave alone all the nice history with elves and monsters and mythical stuff like that. Basically, the problem we are trying to solve is a string validation problem where we will have a bunch of strings with characters. I think it's only A and B, but a sequence of them. And then we'll need to count the number of strings that are valid based on the rule set. And I think it's just easier to look at the input for a second. So very big list. Basically, this thing here that we are going to explain in a second is how the rule to validate the string, the rules to validate the string are actually defined. And then at some point we have an empty line, and then we have all the strings, and we just need to count which ones are valid. Now, I think one way to visualize this problem, even though it's not 100% match, you can imagine that all these rules here are defining like a regex in a way. And then we simply need to apply that regex to every single string here and count the number of strings that are valid. Now, let's try to figure out how the rules are defined. So basically, for every rule, the first part is like an ID. So you can imagine that every rule has a unique identifier that allows us to, say, apply this specific rule. So for every line, we have one rule and one ID identifying that line. Interesting enough, here the IDs are in order. In our input, they are not. They are just in random order. So one more reason to consider this just a generic ID, but it's guaranteed to be unique. It's not going to be like a sequence in order. And then we have, you can already see here that we have 3 different types of things on the right-hand side of the rule. So on the left side, we have the ID. On the right side, we can find 3 different formats. Now let's look at these 2 because this is the simplest case, either A or B. That basically means take one letter from the current string we are trying to validate from the left to the right, and that letter should match the letter here. So if you are analyzing rule number 1 against the first character of the string, that literally means does the first character look like an A? If it is, the string is still partially valid, so you can keep going. If the first character, for instance, was a B, you already know that that string is not compliant with our rule set. Then there are other particular cases. Let's look at this one, where you have 1 and 2. That basically means this is a reference to other rules, and you need to apply a sequence of rules in order. So that means you first go to rule number 1 and you apply it. Then if everything is still matching, you need to go to rule number 2 with the remaining strings yet to be validated and see if everything still validates. So you can already see that this is kind of a graph problem because we need to put all the rules in place, create links between them, and then basically with a given string, we keep traversing this graph, apply all the rules, and make sure that we reach to the end with everything matching, or that at least there is one path that will get us to the end of the string with a matching rule. The last case is this one, where essentially you have like a fork in the rule set, where basically is the same idea, like this is a sequence and this is a sequence, but you need to check both. It's like either this one sequence match or this other sequence match, or even both. So, and the idea is that, of course, at the beginning, we just put nodes there in the graph with their own ID and their own rule, but we don't know where to start. So the starting point by convention is the node 0. So we always start from the rule number 0. Is that clear, Eugen or Roberto, or do we want to see an example maybe?
Well, the rules are quite clear. The problem is converting them in a data structure that makes sense.
Yeah, it'd be worth... Maybe it's worth actually drawing it out now that I think about it. I mean, it's clear to us because we've spoken about it for a few minutes before, but I'm thinking people joining the stream might have the same questions we did.
Yeah, I think I want to just clarify this example here. For instance, in this rule set where we have only 4 rules, they are basically starting from 0, and then they say go to number 1, and number 1 is A. So that literally means every string that is going to be valid starts with A. Then you go to number 2, and number 2 gives you 2 options, either 1, 3 or 3, 1. And you can already see that 1 is A and 3 is B. So either you have A, B or B, A. And essentially all the strings you can generate with the specific rule set are either AAB or ABA. Right? Because it's
Based
like
on
always
rule
A,
0,
and then you have AB or BA. So this is a very simple case.
In our input, there is the set of rules on top and a list of strings to validate on the bottom, right?
Yeah, I'll show it again. This is the entire graph, which of course is much more complicated. And then you have an empty line and a long list of strings to validate.
So
until the end of the file.
Just a quick one to clarify, going back to the original simple one, because that's a lot easier to ask questions on. We've gone through the rule 0, basically, which is the very first one. And that's applied 1 and 2, and it gave us AAB or ABA as possible valid strings. We don't then move on to the next index and so on and so forth. It's literally the 0 index is basically the rules sequence to follow for the entire string.
Yes, if you look in the README, if you scroll a little bit in the README, the question is explicitly, let's scroll a little bit again, okay, how many messages completely match rule 0? So
okay, perfect. That was important.
By messages, we intend one line in the input with all the letters.
Also, might be worth mentioning strings which have more characters than the one specified in the rule set are not valid. Strings which have less characters are also not valid.
Yeah, that's a very good clarification. So I think at this point it might make sense to jump to the whiteboard and try to have a more visual representation of this. So let me share the whiteboard. If I can do that. Yes, there you go. All right, so I'm gonna make this. This is intentionally a little bit more complicated rule set, but the idea is that I want to try to describe how we can visualize this, and that should guide us to figure out how to actually implement data structures that can help us to follow this set of rules. So we said that there are 3 different types of rules, right? Either a sequence of rules to apply, either a fork where on the left and the right side you have 2 options for possible sequences, or let's call them terminal rules, like it's literally 1 character and you need to check if the current character is matching that one. So if we want to start to build like a graph with all these things, what I will do, I will probably start from the node 0, I will use that as an ID. So something that we can use, for instance, using an hash map. We can say, okay, rule 0 is this rule. And every rule can be of these 3 different types. And in this case, if we start from 0, that is going to be a sequence. So we can visualize that as 4. Then you go to number 1. Then you go to number 5. Then we go to rule number 1, and we say rule number 1 is actually a fork. So it splits in 2 options. So you can imagine that there is like a root node that doesn't do anything. And then we go here and we have the first sequence, which is 2 and 3. And the other one, which is 3 and 2.
Sorry to stop you for a quick second there. 0 and 1, are they not nodes, basically?
0 and 1, you mean these ones?
Yeah.
No, these are just IDs for this
So we're going to be
subgraph.
Okay, so we'll be storing these in something like a hash map or something like that, right?
That at least is my idea. We might find a better way, but right now this is what I'm thinking.
It's fair enough. I was just clarifying. That's it. Sorry, it's Monday.
I think the tricky bit is that you don't really have. We are thinking like as a graph problem, but the rules are more subgraphs. Like they are not single nodes, because, for instance, a sequence, as you can see, is 3 nodes of the graph. So that's why I want to kind of store all the different subgraphs in a way that we can easily jump from one to another and follow all the links.
Yeah, makes perfect sense. I just asked that just to clarify, because the top level IDs were, in my brain at least, a bit in the air. So that was it.
No, fair enough. That's a good question. So here is the same. I'm going to speed up a little bit, 4 and 4. And then we have 5 and 5. And then similar thing, we have 3, which is, again, another split. So we can go and we have 4 and 5. And then we can have 5 and 4. I feel like I cannot write today. And then the terminal ones, which are easy enough, because this is literally just match A and then match B. Right? So I think the first part of the problem is going to be parsing the input, the first part of the input, so that, and try to build a structure that looks like this. Then the second part of the problem is going to be always start from rule 0, take the current input string. So you go line by line on the second part of the input. And for every line, you try to apply this rule number 0 for that particular string. If you can find any path in the graph that will give you at the end a terminal node, and that terminal node matches the last character of that particular string, then you can say true, it's valid, and count it. Otherwise, it's false, and you don't count it. And then at the end, you just return the number of valid strings. Now, the tricky bit is going to be, how do we consume a string against this rule set? And I have a vague idea, which I haven't tried, so I don't know if it's going to work. But we could probably do a recursive navigation in the tree, which basically means for every node, you just recurse into the same function. And if that recursion returns true, you return true straight away. Otherwise, at the very end of the function, you just return false. And of course, you need to keep into account the substring that you still have yet to validate, because of course, the more you recurse, the more likely it's going to be that you are successfully validating on the left side and you have a shorter string on the right side.
Yeah, that makes sense. And I'm thinking in terms of data structures, these might make sense as hash maps, which have a string for a key and a vector of strings for a value for representing the graphs. As in, you could have the key 0, which has a vector of 4, 1, and 5 as strings as its value. And you can then use them to reference back to the hash map. It seems like the most straightforward way, I guess.
Could work. What I was thinking, and I don't know if it's exactly the same idea, maybe it's a little bit different, is that in order to describe the 3 different types of rules, we can use an enum.
Because we have the or as well.
Exactly, where basically an enum can be of 3 types. Either is a terminal node, and that terminal node, you know that in enums we can include also values. So that will be of type terminal A, for instance, with value character A. Or the rule number 5 is going to be type terminal with character B. Then we can have the type split, and the type split will be having 2 vectors of nodes. So you can even have recursive enums where they will have vectors of things that can be other rules, because in reality, when you have a split, every node here, like these ones, they are references to other rules. So one way that we can track these references is that we just describe them as other nodes. And I think as soon as I go to the code, it's going to be easier to visualize that. So bear with me for a second. And then the other case is just a vector of references, which is like one line, and you keep going through all of them.
That is another type of the enum, so it will be like a sequence type.
Yeah, so basically, I'm going to try to write it here. That's going to be enum. And then we have sequence, could be 1. And sequence is going to contain a vector of, vec of this enum. What do we call it? Node or rule? Let's call it rule.
Rule, yeah.
So this is going to be a vec of rule, basically. I think we'll need to see if we can do this or if we need to use a box to do a reference. Otherwise, it could be like you are basically nesting a struct into itself, so it's not going to be able to calculate the size of the final object. I think we might have to use box, but let's leave that aside for a second. Then the other one is like split, where you have 2 vectors. So you have vec.
But you can have 2 sequence in a split.
Actually, fair enough. I like that.
That's true.
Again, maybe we'll need to use box, so it might get a bit complicated.
Yeah,
but
okay.
For now, that makes sense conceptually, for sure. It's like, you have 2 sequences and you have to test both. And then the last one is terminal, so term, and that one is just a char.
Yes.
And then we need to create an hash map that associates an ID, which can be a usize or an integer, whatever, to a rule.
To this.
And then we know that we always have to select the rule number 0 and start from there for any given string.
Yeah. Fair enough.
Let's try.
Okay, so
it's possible to debug print something. So we create the hash map, then we print it, and we check what we created.
Actually,
for example, not with the big one, because
absolutely. Actually, yesterday I discovered how to do the pretty print, and it's easier than I expected. So
even an ugly print is something
that can be useful as well.
Yes.
So let me switch to. By the way, is somebody minding the chat? I don't see any message.
I don't see any comment.
We should be
I was
good.
looking, but nobody said anything. I will say hello, though.
Okay, everyone is quiet. So I'm gonna stop sharing this one and share my editor again. And I'm gonna have to do a git reset first because I was already playing with some of these ideas. So my branch is a little bit dirty. Cool. It should be cleaner now. So let me share. Is this readable enough? Let me make it 1 point bigger, maybe.
That's good.
Okay, so let's try by starting defining our types. So we say that we want to do an enum, which is rule. Let's call it rule, if I can type. And rule can be of 3 types. So can be either a sequence, and sequence contains vector of rules. And I'm sure that as soon as we do this, it's going to complain. So let's start by seeing if that's the case. Isn't going to complain?
Nope.
Maybe because vector is already doing like a reference, like a smart pointer? That would be an interesting question if anyone knows in the chat. But let's see, let's keep going. Then if we don't need to use box, that's actually making our life simpler. Then the other one is a split or fork. What do we call it? Fork, maybe it's better. And this is going to be a sequence.
Okay.
Oh, we need to
Are
say
we
rule.
sure forks only ever have 2 branches?
Let's double check. That's a good question. I think I checked, but in any case. So let me search for that. It seems so.
Okay.
That's
Yeah.
good.
Yes.
Okay.
Okay. So this is not expected a type. Found a variant. Oh yeah, because of course you cannot limit to one particular variant. You should just say rule. And
That's actually fair.
That could make sense. And now I think we have that recursive problem. Infinite size. So here is where we are forced to use box. And the way you can visualize this is that if you put a rule object inside another rule object, of course, you can have an infinite amount of nesting. So the size of the object is unknown. But when you put box, it's like you are doing a pointer to a rule that is allocated on the heap. And that basically has a fixed size because it's just the size of the pointer.
Yeah, so you are using the size of the pointer to calculate the size of rule.
I thought we needed to do it here as well.
But probably vector is already doing that for you.
But vector is probably, it's
Because
already
also
a smart pointer.
a vector can't know its size when you start the program. The vector is growing, shrinking.
And the vector is zip allocated as well by default. So, and then the last one is terminal, which is just a child.
Do we want to call it leaf, maybe?
Or leaf, if you want, yeah.
Don't ask me why.
I think it makes more sense in graph terminology. Okay,
so now we have to parse the input.
No, the next thing I want to do is to create another type, a struct rule set or graph. What do we call it? Let's call it rule set.
Yeah.
And that's literally going to be an hash map. Actually, sorry. I need to use parentheses. An hash map of rule. Sorry, usides and rule.
Where's hash map?
Hash map needs to be imported, I think. And it's use std collections hash map. Okay, why it doesn't like that? Oh, because it's angular brackets and not parentheses. And now we need a function that, given the input, is going to give us a rule set.
Go ahead, sorry.
Basically, we'll do create rule set from input, and that's going to be an str and give us a rule set. Or we can even do like an implement block, but just to get the idea. And the other one is going to be validate. And you just pass it a string, str, and a rule set. Reference, and that will give you true or false, so Boolean. So I think these are the two things we need to implement, and then at that point the exercise will be trivial.
That's not happy with the return. Oh, because you're not returning.
Yeah, because we're not really returning our rule set.
Okay, do we want to do we want to find the bits of input that contains rules outside of that create rule set function, as in our part 1 thing, or do we want to pass the entire thing to create rule set and that just consumes what it needs?
I will pass the clean bit. So the first pass is probably to split the.
Okay.
And I think I found an interesting function, if I can remember. there is a nice way to split a string in two and get the two parts. I think that is something like rules and strings, something like that, and equal to input dot. I think there is something like split once. Yeah, it's split once, which will give you an option, and you can pass a separator that can be /n/n, and then of course you need to unwrap because that works only if it's able to find that separator.
Yeah.
And now you have two str rules and string. So let's actually call this one rules. And now we literally want to call let rule set equal create rule set. Actually, I'm gonna remove this underscore because needed. And that should be it. And at that point, we just take the input and try to validate.
But let's do the rule set. As in, let's part the rule set in and see how it...
And we can create a test function and try to print and see how it looks.
Yeah, call it with a simple rule set that we had in the README end.
Yes, you can copy and paste them directly in line.
So let's do, from the README, which one do we want to do?
This one is...
Do we start with this one, which is probably simpler?
Yeah, let's copy this one, and we can copy two of them in if you wish. And we'll just have them for later.
So let's do a test here. Let's do a new test. fn test create rule set. And that's basically input. Well, let's call let rules. And all of this.
It's already got quotes.
I think there is a nice way. I think if we do this and /n, I think. Oh, this is just slash, and here we do /n/. It's gonna be smart enough to figure out what we want, and then we need to escape the quotes as well. Now this slash is basically ignore any white space. So this is like allows us to be multi-line without, and actually we don't need it here.
You need two \n at the end because otherwise the split won't work. But we're just running the test.
Oh no, I'm assuming that that's already sorted out. So let me do this. Oh, we need the semicolon. Okay, so that should be it, and we can even indent. Now let me just make sure that this is correct, just in case. Rules. Now if we run this, we should see the input. We should. Oh yeah, of course.
Because we're not returning.
I
We are
think
returning nothing.
We can add a to-do. We can add to-do, something like that. Would that work?
Open, close the brackets? No.
Yes, cool. So if we run this again. Okay, so the input is clean.
Okay, that's great.
So it's ignoring all this white space for us because we have slash.
Beautiful.
This is another trick I learned. There might be better ways where you don't have to put /n and slash, but I'm not sure. There are so many ways to create strings in Rust. Okay, so now what we want to do is let, what did we call it? Rule set equal create rule set of rules.
Cool.
And then we are just gonna print rules. And I think the way to do the print is this one.
Do we want to?
We are printing rule
set. Yeah.
Rule set. You're right. And this is not possible because we didn't derive the debug trait yet. So let's do that. So we want to do it here. Derive debug. But to do that, this is gonna fail because of course everything needs to be debug. So this guy needs to be debug as well. Okay, sounds good. Now this should be happy. And now if we call this, it's gonna panic because it's not implemented yet.
Yeah.
So let's start to implement this. Okay, so the first thing we need to do is to create the hash map. So let's say let mute rules is let's say is an hash map of usides rule, and it's equal to hash map new. And now we need to start working on every single line. So if we do rules dot lines, we can say for line in rules dot lines, right? Isn't it lines?
It should be
so
lines. You might.
This is. I remember we could do this. Rules is because I called rules and rules. Okay, my bad. So this is row rules. That makes sense.
Okay, that's fair.
Things is hard.
So now we have to get the key from the line.
We could use the same trick, the split ones, to separate
on column.
So we can say let
key
ID or
key, but I don't know.
And rule def.
Rule and definition.
And
then,
key
and definition, sorry.
Yeah, let's actually call it definition. It's more explicit.
Yeah, we are in the context of rules. Yes, we are just doing that in this function. So
split
we don't specify the context in any variable name.
Here we can also specify one char and then unwrap, and that should give us the 2 bits. Now the key is something that we can just cast to usides. So let ID is equal to key parse usides unwrap. And then the rule, the definition gets a little bit more complicated because we'll need to see which of the 3 cases we are in.
If there is a double quote, is a character. If there is a pipe, is a fork. If else, is a sequence.
Exactly. I think that would make sense. So let's see. Which one do we want to do first? The pipe?
We have to take definition and split the definition.
Quote is the simple one. The sequence and the pipe are the more difficult ones, because we want to have references to rules, but the rules may not exist yet. Right?
Actually, I'm going to add here a space, so we don't need to remove it from...
Yeah, how do we do with, for example, we have the first line that is at 0, and it say, I don't remember, it say 1. So we have to point it to a rule with key 1 that we don't have yet in our...
It doesn't matter because we don't expand the rules. We just follow the links. We're going to assume that eventually that link is going to be there.
Yeah, but how do you create a sequence of rules
that don't exist yet? Yeah.
Oh, good point. So maybe we just want the rule ID here.
That rule ID at this point is a usides.
But then, yeah.
And here you have 2 vecs of this. Yeah, this will be a usides.
Yeah.
Maybe it makes more sense to do this at this point.
Yeah.
Okay. And
sorry for bringing it up.
No, that's a very good point.
It's true. It's true. Okay, let's go with this. It's simpler to implement because we don't care if the number is not there yet. We know that the rules are valid, and one day they will be.
Yeah,
exactly. Maybe for additional clarity, what we could do is to do an alias type rule ID equal usides.
Sure.
And I think that will be a little bit more clear. What are we trying to do?
Yeah, that's fair.
And then in line 13, you do dash map of rule ID to rule.
Yeah.
Fair enough. Yes, we can do that as well. Here we don't even need to do this anymore. I think it will figure it out. And then this will be rule ID.
And don't forget line 16.
Yeah.
By the way, you guys can still hear me, right?
Yes.
Cool.
Yeah.
Checking, because I think my mic is drifting in and out today. I don't know why.
We are
So
just not caring what you say. It's not listening to you.
Yeah, exactly. I'll find more interesting things to say, yeah.
So what I want to do is, I don't know if there is any better way to do this. This is very ugly, but literally, if we can match one quote, this is the easy case, where
Okay.
it's just a leaf, right?
Yeah, sorry, I was trying to read
This is a leaf rule.
Is there any combination where it's a conditional, it's a fork of either a character or a reference?
Not that I've seen, but let's
Not that
double
I've
check.
seen.
Sorry for asking about all of these weird
No, but
things.
that could be a
Oh, they are
possible.
good edge cases, but I don't think there are. B is a B.
Let's check all the quotes. Oh, there are only A and B, line 91 and line 112, 92 and 112.
Probably there will be something
Okay.
in part 2, but let's care about part 1 now.
Yeah, okay, fair enough.
So how do we create a rule of this case? This should be simple enough, right? We can say let rule is equal to rule
colon leaf.
And the value, we need to parse it. So how do we parse the value? Is going to be actually the next character, right?
The next
let
character, yes.
Yeah.
val is equal to definition chars nt h 1.
Yeah, can I just create definition chars before the if without creating it again inside the
That's
if?
what I was going to suggest as well. Have a single iterator. As in have the chars above. And just call next.
I suppose yes, for this particular case, but in the other cases, you'll need a fresh
Okay,
set
let's
of
leave
chars,
it like
right?
this now. Let's go.
Yeah, let's keep it stupid, and then we'll figure out how to write it in a nicer way.
Correct.
It's already complaining here, by the way. You should use starts with, for instance.
Which is fair.
Which is already nicer, right? Starts with this guy. Thank you, Clippy. Okay, and now we are just saying
and we have to put the rule in the map.
Yes, so now we need to do.
So we can create the rule outside the if and put it in the map after the if, because we are creating other kind of rules.
Yeah. No, we can't.
No, because we want to insert one specific rule. The terminal one is always 1, basically. This is the easy case. The next one, I think we need to do a vector and then create a rule out of it.
Okay, it changed the types, right? You're right.
Yep.
Types are different. So not types are different. They're always rule, but the stuff inside the enumerate is different.
Yeah,
so this would be ID and rule.
Yeah, well, no, but we'll see if there is a...
Now the other thing is definition contains a pipe.
Yeah.
I think we can just do this, right? I think so. And then the third rule. So this is a fork, and this is a little bit trickier to write. And then the last else will be, and we probably don't even need to use the else. This is a sequence. Okay, so let's focus on this one. This one is interesting because we'll need to create 2 vectors. And then we use them left and right. So I think we can split on this one. We still use the same trick of split ones. So let's call it left and right. And then this is equal to definition, split ones. And we can use space, pipe, space, I guess. So we remove all the space and unwrap.
Well, the numbers are still going to have space in between them, but that's good.
Now we can split left. So let's do left IDs. I'm gonna call them, and left IDs is gonna be a vector
Left.
of
usize.
rule ID.
Yeah, rule ID. Sorry.
And this is basically gonna be a left dot split
Dot map.
Space.
Dot collect.
dot map.
No, or collect. Collect is not casting the type. No, we have to map with the parse.
I think we need to do the parse and unwrap. So we need to do x and then x dot parse, unwrap, and then collect. I think that will work.
Okay.
Let's see.
Seems happy.
Yeah, it did figure it out. And then literally we can copy paste all of this and do it with write.
Yeah.
Now again, we might improve this a little bit.
Mm-hmm.
This is right. For instance, one thing we could use like a parse, like a from str in rule.
Later.
We could implement that. And then we can probably call itself into the two sides and be a little bit smarter. But for now, let's do all the grunt work.
Yeah.
So now the let rule is literally rule dot column fork, and then the left side is left IDs and right IDs.
Yeah, what I was saying before is that we could create let mute rule of type rule before the
you're right.
and assign it inside and put it in the hash map after all these.
Like as a mutable rule, and then you will that work? Probably yes.
Let mute.
So let's do let rule. I think we might get
type,
away with this
of type rule. Oh no, well,
of
it's really
type
fair.
Rule. I think it might work. Let's see.
Yeah, don't do let in line 26 because you are letting twice. Remove the let in 26 and 32.
And 32, yeah.
Oh yeah, we just need to say rule equal.
Yeah, because it's already defined. I don't know if you have to put it mutable or not.
Let's see. Now here it's going to complain because it might be initialized or what?
Because it's moved.
And the move occurs line 13. Why?
13.
Line 5 value.
No, that's
oh no,
the
this
column.
is 38. 38 is
Left IDs. Oh, because you're splitting. No.
Because you are creating val inside the if.
Oh, we need to use a reference here. Is it?
Yeah, but now the data type is wrong.
Yeah, because it's not a reference to a rule. Okay, let's leave it as it was because it's easy enough.
We might have the same problem anyway, but
yeah, I think so. But let's revert. Yes.
Yeah,
sorry.
but at least
here what we want to do is this.
Yes.
Right
but
now,
I think that we are going because we are not returning rule now. But when we return rules, it will complain that
exactly the same problem. We'll see. Let's give it a second.
The last one that we say is the sequence that is just a subset of this.
Exactly. So literally will be this, where we call it, I don't know, sequence. And this is going to be definition. We might have to do a trim. Let's see if it explodes. I think we might have to do a trim. But anyway, then we have let rule is equal rule dot sequence. And this time we pass sequence. And now again. And finally, we return rule set. We don't need to write rules.
And now he's complaining. The type definition of return function is still.
Is it?
No. This is hash
no,
map,
because this is wrapping the hash map. So we'll need to return rule set of rules.
Okay.
Because I didn't declare this one as alias. But more as a wrapper. It could be an alias. I'm not sure if we can do this. So that's the only reason. I think here we can implement more functionality.
And he's not complaining anymore about the
move.
Yeah. So let's see if our test does something meaningful.
Yeah, let's test it first. Let's run this and see what happens. It didn't explode, which is already amazing. Now let's try to visualize if this fits the screen, what we did. So rule number 0 is a sequence of 1 and 2, and that looks okay. Rule number 1 is an A, and that looks okay. Rule number 2 is a fork of 1 and 3 and 3 and 1, and that looks good. And rule number 3 is a B.
Beautiful.
Do we want to try the other case?
Yes, copy and paste the bool function and change the input.
So let's do this.
We can also can we assert on struct so complicated?
I wouldn't.
I think we could create, if we implement like equality as well here, we could just create manually one and then assert that they are the same.
But well,
maybe that will work.
Let's not do that now. It's just it was just a question.
I think you can do it for sure. You just need to write the struct by hand.
There is nothing like snapshot for JavaScript. You run the test, it fails, you say save this as a snapshot, and then you run it again.
I'm sure that there is some crate. I don't know if there is like a native feature for that.
Ask it.
By the way, the easy way
go ahead.
The easy way we can implement that is that we literally highball the result there, right? We just copy paste that in a string, and we check that this string like this matches this one.
We use format.
Exactly. We use format. We get a string that contains all of this, and we manually copy paste this one.
Tommaso says that it should also be serializable, as in the hash map itself.
So if it is serializable, it's possible to.
But I think because we're using strings and usizes, I think it won't complain, right?
I think so. We are not doing pointers or stuff like that.
Yeah. Anyway, okay. For test with snapshot.
For test with snapshot. Do you have any pointer on how to do snapshots? No, I don't think we will do it now, but it will be interesting to have a link.
Yeah.
To a crate to do that, yes.
Or if it's included, how to do
it. Nope, no link. Okay, we'll look it up.
Okay, we'll copy and paste the other example.
Let's do it.
Copy and paste. I copy pasted this one. Let's take the input. Sorry, from readme.
Yeah, the other example.
This one, right? A little bit more complicated.
Exactly.
And we'll do it here. We tab and then /n. No, /n/ we do this for every line, and then we'll need to fix the quotes. And this one only needs /. And now if we do this guy, we should get a different tree, a different graph with hopefully
415.
So 415 is good. Then we have leaf A for rule number 4, and we don't see the exact same order because it's an hash map, but 4 is an A, 5 is a B. Then we have 3, which is a fork, and is 4554, 4554. Then 1, which is 23 and 32, 23 and 32, and then 4455, 4455.
Also, Tommaso sent us a link to RS Test, which is a fixture-based test framework.
I heard of this one. I actually saw an example where you can use like macros to define table of inputs and expected outputs and run the function against that table. So that could be interesting to play with one of the next episodes, or maybe this one if we have enough time. Thank you, Thomas.
Like 9 minutes.
Yeah, I'm not very positive that we have time today.
Okay, but this was already good progress. Let's start to see how we could use this data structure, right?
Yeah.
Yes.
I think the next step here for part 1 will be
taking the strings line by line. Let's take the first
piece of input.
Well, to be honest, we can write a test from the README, because we can copy and paste one of the 2 tests that we wrote now. Then we take a string that we know is working, because in the README there is examples of working strings for the rule set, and we create a function that return a boolean that tell us if this string with this rule set is valid or not.
Yes, fair enough.
Yeah, that's true. And
Then
we should
do
know
this
whether
on
we
the
pass.
small data set without all the input on our back. Then we do the big part.
Okay,
Also,
but here, once we have this should be fairly simple, because this will be
counting
strings dot lines dot filter or filter
count.
map. Filter.
No, we have to filter the one that are matching, so the one that they are valid. So
you want to call lines, by the way.
Oh yes, thank you. That's why he wasn't very happy.
I don't know if you want to call the function is valid, but let's call it something.
Validate we have, right? Validate, and we need to pass S, and then
the rules, and a reference to the rule set.
Rules set.
And in the end, count len. How do you count?
And then count. And this will be let solution.
Now, that will be the solution. Don't let it. Just
that we return. Yeah. And now I'm not doing it because otherwise we'll break the test. So I'll keep this one commented maybe. But that will be literally the idea.
Yes.
Yeah. So
okay, we can write a small test for validate with the simple rule set that we are coded, and with one string that we know is valid, and one that we know is not valid, and we start.
We test these two basically.
Yeah. We know that the BBB is invalid, and we know that the ABA is valid. And the ABB is not valid, so we know some solutions.
Sure.
Okay, I am starting to feel like we need here the first rule as well in the inputs.
We also start with 0.
But we know it's ID, yeah.
Now, if we want to make it recursive, but let's start to write all the cases.
If we want to make it recursive, we can add it later.
Oh yeah, with the usual wrapper trick that we also use in the previous.
Wrapper, or passing really a 0 at the first call, but who cares?
That's true.
But basically,
go ahead, Luciano.
Add a third parameter with the rule.
Yeah, so start.
The current rule, because it's not start rule. It's called the current rule ID.
And that will be
size.
Either a reference to a rule or
rule ID.
Or a rule ID.
Yeah, a rule ID. And in line 53, the third parameter is a 0 because.
Yeah, we know that that's always the case. So
we put a comma 0 so we don't forget. Next time we don't take alpha now to remember it.
One interesting thing that I noticed while looking at the input is that, so just for context for everybody else watching, we spoke about this for a few minutes before, and Roberto and myself were thinking about pre-calculating all the paths through the rules and kind of replacing forks with actual characters and so on and so forth. Looking at the input, it seems to be, well, it seems you only have 2 rules and about 100 or so lines of references of rules going from and to each other. So as a potential performance gain, next time we can actually try that version as well, as an after we solve it. Yeah, once we have a working solution, of course.
And to just phrase what you said in another way, it basically means like if we were changing this input to have every time there is a 1, we use A straight away, so this will become like
A3.
And every time there is a 3, it becomes a B.
Yeah.
And everywhere you find a 1 and a 3, you replace with A and B respectively, and then you simplified all the rules.
Then when you find a 2, you have to fork in 2 strings because the 2 is a fork again. So it will be 0 will be a list of valid strings, but it will.
Yeah. Exactly,
Yeah.
pre-calculated.
In the end, 0 will be one rule with a list of valid strings. A set is better for looking into, but because
Yeah.
it's O1 instead of O-N, the finding stuff inside, but that's another problem. And at that point, you just take the string and you search inside it and you say, okay, matching, 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 not matching, and so on.
Okay.
In any case, we have to implement, we have to start with something like this.
Yeah.
Do we want to give it a first draft? We're not going to be able to finish it, but we can start to structure
we can start to write some.
Yeah, let's start on it.
So basically, I consider this is a recursive solution, then we'll see if it doesn't work, we'll change. But what is the base case?
So if the rule pointed by the rule ID is a leaf, we have to check the first character in the string with the character in the leaf.
So rule is going to be rule set
of rule ID.
Dot.
Wait. How do we manage the current position in the string, by the way?
Because when we call in recursion, we pass the string with a
substring,
yeah.
A reference to a substring.
So the rest of the string. So we always have to look at the first character of the string.
Exactly.
Okay.
So rule set. Why do we don't do
0? Because he's encapsulating the hash map.
Oh, that's why you're right.
Yeah, rule set is encapsulating the hash map. I don't know .0. Yeah, .0 .get. Yeah.
Okay. And then I don't think we need this, do we?
We can match. We do.
Yeah, we can match and do an if like.
And now we can do match rule. And we have the three cases. So rule, leaf, which is the easiest.
Yep.
C.
And we'll do in a second. And then rule dot sequence. And then rule fork. Right, and at the end of the day, we return false, but inside here, we might be returning true.
But no, well, probably it's the other way around. We are returning true in the end, and probably we are returning false in the matches, but let's see.
Okay, that is also, fair enough. That could be.
Okay,
so now, of course, this is complaint because when it's leaf, we need to give it names, right? And here we have sequence, which is sequence, and here we have left and right.
Okay.
Why are they still complaining?
Because we are doing nothing.
Option. Why is an option? Oh, yeah, because here we need to unwrap, because this guy might not exist.
But well, we know that
we know it's going to exist, so let's unwrap for now. So, okay, char. So what do we do if it's a char?
If the first character of the string is different from the char, return false.
Okay, so basically we do.
We know.
Yeah,
Tommaso.
We know. We trust our input. Yeah.
Sorry, should work. I meant TM.
So the new works in my machine works with my input.
Yeah. Exactly. I'll just be the user of this.
I will give you a error, and it's a failure in the test if you panic.
So I agree with Tommaso. Or go ahead. Sorry.
If C is different than
from the first character of str, how do you say that?
So string dot chars dot
first
next dot unwrap. Beautiful. Or we can use again starts with, right? String starts with C.
If
or
not,
in this case not,
we return false. So game over.
And this is doesn't need what a reference or wants a string. What's the signature here?
Pat.
What is a pattern?
Pattern can be a star, a star, or a char.
A reference to a string or a char. But it is a char.
Put a star because C is a reference to a char.
Fair enough. Good point.
Okay. Remember to make line 58 true, because otherwise we are not going to work.
Yeah.
Okay, and now we have if this worked, so after line 52, if the char is not giving us false, right, we have to return
nothing.
No, we have to go on in recursion with the rest of the string if there is something.
But we don't have any more rule. This is a terminal.
This is a terminal
well,
node,
okay,
yeah.
this is a terminal, so done.
Somebody else will have called us recursively, so that should be it.
Yeah, you're right.
Yeah.
So done.
Yep. Come on. Let's
that's why I was thinking that this is the opposite, to do the opposite.
And what if there is some string left?
Oh yeah, so we need to check both.
No.
No, we are checking outside.
Yeah, leave it as it was, and let's implement the other two, because the other two will make it a lot easier to see this.
Okay.
Specifically
so
sequence
false.
rather than.
Sorry, this was not.
Yeah.
And return false, and this one returns true.
Yeah.
Okay, let's check the other one.
Yeah.
So a sequence, basically what we want to check.
For a sequence, all the rules must match in sequence str.
Yeah.
No?
Yeah, so you call yourself.
But then we don't really know
where we are in the string.
Yeah, how much string we consumed.
Okay,
yeah.
I'm thinking.
You can.
Oh, I have another idea.
Oh.
Maybe. What if this guy returns a result with the remaining string?
Can be useful.
And by that, I mean that it can be either an error that means didn't match, or if it did match, it will tell you how much string is left.
Yeah, it can work.
Okay, so we do result of str. And basically, of course, now it's going to complain, like false. Why is it not complaining?
Because it's not a result.
Two generic arguments. Oh, yeah, because when it's an error, then we can return option, maybe, to keep it simple. Or, I mean, we do a result and an error. Error, let's use... what do we use? Do we use just a string for errors for now?
I don't know exactly what you are doing, but I believe in you.
Okay, let's use an option because it's simpler to reason about. Because otherwise we enter the world of errors, and how do we manage errors? Now, option T, why you don't like that? Because lifetimes.
Lifetime recursion.
Yeah, beautiful.
Can't we pass to validate instead of a string an iterator of character?
Done. I think that's
we
done.
know where we are because we are consuming characters now, because there are fork.
Because you might need to go back.
Yeah,
depending.
You need to go back in multiple directions, so it can be one iterator. At least if you can't split an iterator in two in Rust, like creating a copy of an iterator in the point it is. No idea. But well, let's go with the option of a string. So if the string is not matching, we are returning an error.
Return none.
None.
And here, for now, let's just return some with an empty string, just to make it happy. Now this is... sorry.
But, well, you can do in...
I mean, this will be the happy case, right? When you finish everything.
Yeah, but in line 52, probably, after line 52, you can return what's left of the string, because the string is valid. The first circle of the string is valid, right?
So we can do this. So if it matches, then we return. Or you want to do the opposite logic?
Oh, I don't care.
I think it's more obvious if we do this.
Yeah.
Sum, and then we do
S1 column dot, right?
String,
yes,
and we do
one dot.
One dot. Yes, I think.
And outside
And
of
it needs
if,
to be a reference.
it's not doing a reference automatically.
I don't think so. I think if to do a slice, you need to put a reference in front.
Okay. And outside of that if, return none, because it means that we failed.
Mm-hmm.
Here it means, okay, it's not matching. Game over.
Yeah.
Mm-hmm.
Now, if it is a sequence instead, we have to
Now
match all the rules.
In order.
By the way, I'm
In
thinking
order.
we can make this one even simpler
Okay.
as we implement this.
Okay, we are returning the... Okay, we got it.
Why did you
And
format
now,
it?
the linter... don't save
Okay.
until we are not done.
So now we can do that trick where we can do like a for loop, right?
Mm-hmm. Yeah.
And we get the current result and we keep going if it makes sense. Okay, so what we do is for rule in sequence,
Mm-hmm.
right? What we want to do is to call
Validate.
ourselves recursively.
Yes.
So
validate.
let's do let next,
Yeah.
right?
Yeah.
Is equal to validate of
String.
current string. So string.
Colon.
Then rule set is always the same.
Same.
And then current rule is gonna be rule.
Okay.
Rule. Oh yeah. Wait.
Yeah, rule. You call it
Rule is the ID, right?
Yes.
Yes.
Okay.
And that's it. Now, if
some next.
If next is none, it means that didn't match, so we can stop here, right?
And we return none.
And we return, well, we can just say, return none.
We can optimize later. Otherwise, we have to go in the next cycle.
Otherwise, we keep going to the next cycle.
But now
but we'll need to return next. The last next
must be next. Yes.
So let's do. Can we do
next equal string?
Equal some.
No string. No
string.
Okay.
A string or str?
Oh, you know what? Wait. I have an idea. So let's do string.
Okay.
That.
Then in line.
And now here we do if let
result.
I wanted to do something like this. I don't know if it makes sense.
Yeah, but then validate next, not validate string. Invalidate.
Next, yes. Will that work?
There are a lot of...
Because I don't know if you can do different there, because that's what we want to do. No, I think we need to do it explicitly. I don't know if we can be smarter.
No.
So let...
Yes, I think this, like Tommaso was saying, could be a method in the rule set, so we don't have to pass the rule set around, but we can optimize object-oriented this later.
Oh, let's do let maybe next. I'm going to do it this way for now for lack of better ideas. Okay. And then what we want to do is if let some, or what we can do if maybe next is none, we return.
None, and we are done.
Otherwise, next is equal maybe next dot wrap.
Yes, because we know. There was a suggestion in the comments about if let r equal, but I don't know what it means. So if Luciano wants to take a look.
Just a second. Okay.
Yes.
If let r e, but we are not using a result. We are just using an option.
Okay. So
So that will be something like if let none, I guess, equal, but then we don't really have a way to propagate next.
Why is complaining about the rule ID in line 58?
Think maybe some reference thing. Consider the referencing the borrow. Okay. Because, wait a second. Now, why doesn't like it here?
Must be mutable.
Oh, of course.
And now it's complaining because... Thank you, Rust. Okay,
this block might be rewritten with a question mark operator.
Not now. Don't bother.
Ooh, quick fix. Let's see what happens.
Oh my God.
Is that really doing what we think? I think so. Interesting. So this is literally doing, if it's known, just return
known.
Okay.
A little bit cryptic, so I'm gonna say if none, return none.
Good idea.
So we remember.
Okay, this one will go through all the rules in the vector, and if there is only one that fails,
wait, Thomas is giving us an even better suggestion. Just put the question mark here, and that should be basically everything we need. Next is equal all of that. Right? Nice.
Cool.
Okay, so we don't have to use the temporary variable.
Thank you, Thomas. This is pretty cool.
Yeah.
So basically, recapping, this is taking all the rules and validate all the rules recursively in the sequence, obviously with what's left of the string. Now, the fork.
The fork is literally copy-paste, right?
Yeah, this is an AND, but the fork is an OR. The sequence is an AND operation. The fork is an OR operation. So if one of them fails, we don't have to fail everything. We have to fail if all of them fail. But even just one of them go on, we go on.
Yes.
So it's not exactly the same. So we try left, we try right.
If one of them's okay, yeah.
Yeah, if one of them is okay, we go on. Otherwise, we go on with the string left from the one that was successful, not with one failing.
So what I'm going to do...
Or they can succeed both of them, and so we have to go on with both of them. Because it can be that a fork succeeds now, but then it fails later. No, or it's not that is not possible. Question. It was a question, not an affirmation.
I think we can continue with recursively following every single path, but every branch eventually needs to return true or false.
Okay.
As it is.
So in the end, if they are both true, true. It's an operation.
Yeah. Now, guys, unfortunately, I have to go.
Do we want to leave this one for next time?
Yeah, let's do this next time. Let's put a comment. This is an OR of the previous.
This is an OR.
Like the previous step, but we need to do it for both left and right. If any of the two works, we
go on.
Now, I'm not sure which string will return, but we'll see. So
if both of them fail, we fail.
Yeah.
Okay.
Cool.
Okay, we'll do this next time. Cool. So
I'm gonna commit, but meanwhile, you guys can do the closing.
So let's wrap it up. You can find the recording, or you will find the recording on YouTube. Give us some time. The link is on the Twitch in the About section. If you're watching this on YouTube, we do live streaming on Twitch every Monday at 5 p.m. UTC. That is 6 p.m. Dublin time. That is 7 p.m. Central Europe time, and so on. We can go to Japan and backward to LA. Make sure that you check the Twitch link, follow us, send us money, do everything, the usual stuff. Subscribe, alerts, everything. Come on, everything.
And
Feel
pull
free
requests.
to give us comments. Feel free to send us PR with better code. Our code, like you see, is full of unwrap, and we like them a lot. The repository is at the banner.
There.
At the banner that is here. Everything is accepted. We are trying to learn Rust. Don't expect our solution to be the cleanest, except for the pull requests that are cool, that posted by people. If anybody can know better ways of doing stuff, tell us. We like to learn. Thank you for all the suggestions, for the people in chat. And now we write somebody.
No, because I'm not ready for it, so I think we'll
Yes,
skip the raiding this time.
Okay, we are not writing anybody this time, so they will survive. Thank you. Bye, and see you the next time.
Bye.
Thanks. Have a good one. Bye.